a real technological breakthrough for its time, and was it stealth?
An artificial intelligence just reconstructed the lost blueprints for the Horten Ho 229. The original plans were gone, but the AI used scattered data to bring the design back. The thing is, the final blueprints are terrifying. They show a wonder weapon that was far more advanced than anyone knew. We're talking integrated stealth, electronic warfare capabilities decades ahead of their time, and a clear plan for supersonic flight. This wasn't just an aircraft, it was a platform, and the AI just proved it was almost a reality. An alien among the relics. Near Washington, D.C., inside the massive Stephen F. Udvar-Hazy Center, something strange sits among the aviation legends. It's an aircraft that looks completely, utterly alien. It's a seamless, boomerang-shaped wing with no tail, no fuselage, just pure, flowing ambition frozen in plywood and steel tubes. This is the Horten Ho 229 V3, the only surviving prototype of its kind on Earth. For decades, this machine has been a tantalizing puzzle, a what-if of history. But here's the problem. It's incomplete. It's a ghost. American forces captured the V3 at the Gothaer Wagenfabrik, or Gotha Wagon Factory, in April of 1945. It was found in the dying days of the war in Europe, a prize seized from a collapsing regime. They found it just before it could make its first flight. For 80 years, it sat in storage, its secrets locked away because the most important pieces were missing. You see, the original blueprints were scattered across bombed-out facilities, or in many cases deliberately destroyed by retreating forces. Its manufacturing specifications were lost to the chaos of the war's end. And the complete aerodynamic calculations? They were buried in personal notes that were never fully documented. What survived were just fragments. We're talking partial drawings that showed different versions of the same parts. There were contradictory measurements that couldn't all be correct. And of course, there were witness testimonies from workers and pilots that seemed to change with every retelling. The Smithsonian's Preservation Project did an amazing job. They documented every single rivet, every panel, and every structural detail. And yet, the biggest questions remained unanswered. The V3 prototype revealed how it was built. A simple-looking plywood skin stretched over a complex steel tube frame. It had a radical weight distribution, and it featured a mysterious dark adhesive, almost like a charcoal paste, packed between the layers of wood. Some people claim this was a primitive attempt to absorb radar, but without the plans, this was just a guess. What about the V2, the earlier version that actually flew? What about the planned production models that were supposed to follow? In 2008, the aerospace giant Northrop Grumman, the very company that builds the B-2 stealth bomber, decided to find out. The B-2, of course, looks eerily similar to the Horten. They analyzed the V-3 down to the millimeter. Then they built a full-scale, non-flying replica using the exact same 1945-era materials. They put this replica on a pole and tested it with modern radar systems. The results were a wow factor all on their own. The Ho 229's radar cross-section, its size on a radar screen, was roughly 20% smaller than conventional fighters of its time, like the Messerschmitt Bf 109. But the real kicker was something more specific. The shape and the charcoal wood composite made it almost invisible to the specific type of radar used by the Allies in World War II, the chain-home system. Was this intentional stealth design, or just a lucky, fantastic accident of its aerodynamic shape? Without the complete blueprints, the answer was always elusive. Traditional reconstruction methods just hit a wall. Aviation historians spent decades, literally lifetimes, trying to redraw the plans. They all failed. But what if a new kind of intelligence could see patterns that humans couldn't? This is where a radical idea began. A consortium of aerospace engineers and computer scientists proposed using a quantum-inspired AI to finally reconstruct what the Horten brothers never finished. They decided to feed everything into these advanced algorithms. Every photograph, every partial blueprint, every smudged measurement and contradictory note, every witness account. every single data point from those Northrop Grumman radar tests. The quantum AI system used generative models, much like the ones that create art, but trained on thousands of aircraft designs from history. It combined this with quantum-inspired optimization solvers that could explore millions of design possibilities at the same time. The AI's task was massive. It had to grasp 1940s aerodynamic theory. It had to understand the material science limitations of wartime Germany. It had to know the specific manufacturing capabilities of the Gotha factory. And most importantly, it had to learn the design philosophy of the Horten brothers, Reimar and Walter, derived from all their earlier, simpler flying wing gliders. The puzzle was finally being assembled. But what the AI found wasn't just a simple aircraft, it was a terrifying glimpse into the future. A plane with no tail. The AI reconstruction worked in layers. First, photogrammetry data. Piecing together thousands of photos created a perfect micrometer-accurate 3D scan of the physical V3 prototype. Then the system analyzed the few surviving flight test notes from the V2, the one that actually flew. It looked at its estimated speed, its handling, and its climb rates. It then began reverse engineering the exact aerodynamic properties needed to produce those results. Next came the pile of partial blueprints. This is where quantum-inspired computing proved its worth. You see, a traditional computer would process these contradictions one by one. It would get stuck. It would say, "does not compute." The quantum-inspired algorithms, however, evaluated multiple design solutions all at once. They tested thousands of structural configurations against the flight performance requirements in parallel. Millions of iterations ran at the same time, checking and cross-checking every fragment of data. When aviation experts approached the AI's finished blueprints, they were deeply skeptical. An AI can make mistakes. It can create beautiful nonsense that looks perfect until you actually try to build it. So the validation process began, and that's when people started paying serious attention. Engineers at the Technical University of Munich built a scaled model based on the AI's new structural predictions and put it in a wind tunnel. The results were staggering. They matched the original V2 flight data perfectly. The computer had rediscovered 80-year-old engineering solutions from scratch. Then the AI tackled the engines. The Ho 229 used two Junkers Jumo 004 turbojets. These were the same engines used on the Me-262, the world's first operational jet fighter. But the thing nobody tells you about these engines is that they were, to put it mildly, terrible. They were rushed into production. They had a lifespan of only 10 to 25 hours, and they were famous for flaming out or catching fire. The Horten's design buried these two fire-breathing engines deep inside a wooden wing. The precise mounting configurations had been lost. This was a huge mystery. How could this possibly work without the whole thing just burning up? The AI analyzed the airflow requirements, the thermal management for all that heat, and the weight distribution constraints. This mattered because engine placement fundamentally affects a plane's stealth. The AI's reconstruction showed the Ho 229's engines would be partially shrouded by the wing's trailing edge. This would reduce the radar and infrared or heat signatures from behind and below. It also showed a clever series of cooling ducts and heat-shielding materials that were planned but not fully installed on the V3. This was integrated signature management decades before the concept even had a name. The AI also decoded the Horten brothers' design philosophy, uncovering decisions that historians had misinterpreted for decades. Take the wood construction. Most analysts just saw this as a compromise. Germany was running out of metal, so they had to use plywood. The AI suggested something entirely different. Wood offered specific advantages. It could be formed into complex, smooth curves more easily than metal. It provided natural vibration damping for those shaky turbojets. And most importantly, it had a significantly lower radar reflectivity than aluminum. The AI cross-referenced the wood specifications with German research from the time into electromagnetic properties. It found 1943 lab papers studying the radar absorption of various substances. And what was at the top of the list? Charcoal. The mysterious adhesive wasn't a myth. The AI's analysis showed that the specific mix of charcoal, sawdust, and glue created a composite material that was remarkably good at absorbing the specific radar frequencies used by the British. The timeline aligned perfectly with the Ho 229's development. But the AI revealed the stealth was likely a secondary benefit, not the primary goal. The Horten brothers were obsessed with aerodynamic efficiency. Their flying wing designs, going back to the 1930s, were all about minimizing drag. Smooth contours, blended surfaces, and getting rid of unnecessary parts like a tail. These were efficiency decisions first and stealth features second. The genius was that they recognized and exploited this dual benefit. What many overlooked was the control system. How does a plane with no tail and no rudder turn? The AI Reconstruction figured it out from the fragments. The Hortens used a complex system of elevons on the outer wings, acting as both elevators and ailerons, and crucially, a set of spoilers near the wingtips. To turn left, a spoiler would pop up on the left wing, creating drag and pulling the plane's nose to the left. This was an incredibly advanced system, and the AI rebuilt it. Finally, the Reconstruction tackled one of the Ho 229's most debated features: its claimed top speed of over 1,000 kilometers per hour, or about 620 miles per hour. This was part of the 3 times 1,000 requirement from the head of the Air Force. Carry 1,000 kilograms of bombs over 1,000 kilometers at 1,000 kilometers per hour. The AI's high-fidelity aerodynamic model, combined with accurate engine data, settled the debate. At sea level, the aircraft topped out around 950 kilometers per hour, about 590 miles per hour. But at high altitude, above 30,000 feet where the air is thinner, 1,000 kilometers per hour was achievable under specific conditions. The AI also identified subtle handling features, like a specific wing twist and strategic mass concentrations. Engineers tested these in modern flight simulators. Test pilots were shocked. The Ho 229 was challenging, but it was flyable. It was far more stable than it had any right to be. But the AI also found structures inside the wing that made no sense, at least not for a 1945 aircraft. A weapon from 1960. By completing the blueprints, the quantum AI also revealed the timeline. It showed what could have happened if history had turned just slightly differently. The Ho 229 V2, the second prototype, first flew on February 2, 1945. The test pilot, Erwin Ziller, reported that it had excellent handling, but the story turns tragic. 2 weeks later, during the third flight, one of those unreliable JUMO engines flamed out during the landing approach. Ziller tried to go around on the single remaining engine. The aircraft stalled, spun, and crashed. Erwin Ziller was tragically lost. That one moment, that one engine failure may have changed aviation history. At the time of the crash, the V3, the one in the museum, was still under construction. 3 months later, Germany surrendered. But what if Ziller had survived that landing? Or what if the engine hadn't failed? The AI's timeline analysis suggests the V3 would have been completed by late March 1945. Production approval for 20 aircraft could have come by early April. The first production aircraft might have been operational by June 1945, just 2 months after Germany's actual surrender. This isn't just idle speculation. The AI Reconstruction answered a crucial question: was the Ho 229 actually producible? The analysis determined that yes, it could have been mass-produced with 1945 German industrial capacity. The design didn't require exotic materials or impossible precision. It was radical, but it was buildable. Imagine just 20 Ho 229s operational by the summer of 1945. They couldn't have stopped the Allied advance. The war was lost, but they could have significantly increased the cost in bombers and crews. The AI modeled combat scenarios using historical data on Allied air defenses. The aircraft would be devastating in hit-and-run attacks. It would be vulnerable in a sustained dogfight, but it would be extremely difficult to catch once it disengaged. Its speed and, crucially, its low radar signature would have baffled the radar operators protecting the bomber streams. But the real wow factor came when the research team received access to newly declassified documents from the U.S. National Archives. These were intelligence reports from 1945, sealed for 80 years. The documents contained interrogation transcripts of Reimar and Walter Horten after their capture. They also had technical assessments by the American engineers who examined the Ho 229 V3 right after its seizure. What those documents revealed stopped the entire research team cold. The American engineers in 1945 had found something in the V3 that was immediately classified and then subsequently lost in bureaucratic archives. They found a structural cavity in the wing's center section. Inside this hidden bay were the fragments of electronic equipment, completely burned out but present. The 1945 report speculated that this might be a new kind of radio or navigation system. They cataloged it, photographed it, and then apparently forgot about it as higher priorities took over. Here's the thing. The quantum I had predicted this cavity's existence. It wasn't on any known drawing, but based on an analysis of the V3's electrical system layout and its power distribution, the AI suggested the cavity was designed to house something specific. It was an advanced radar warning receiver operating on heterodyne principles. This isn't just any radar detector. In simple terms, it was a system that could listen for Allied radar, analyze the signal, and warn the pilot. This was technology not publicly developed until the 1950s. The AI had reverse-engineered its existence from subtle wiring details, power requirements that were way too high for simple navigation gear, and shielding patterns that only made sense for sensitive radio frequency equipment. When the team compared those long-lost 1945 photographs of the burned fragments with the AI's predictions, the match was undeniable. The component mount spacing, the cable routing, the power connections, even the fragment size and placement, everything aligned. The Horten brothers had attempted to install what amounted to an early electronic warfare system in their stealth aircraft. The concept was complete. Use the stealthy shape to get close, use the detector to know if you've been spotted, evade before detection is confirmed, and strike from a blind angle. It was an integrated stealth philosophy, not just a passive one. But even that wasn't the discovery that left the experts truly speechless. The AI found something else. 200 units. The moment of truth came in October 2024. The development team presented their complete reconstruction at a closed-door symposium. It was attended by aerospace historians, aeronautical engineers, and military tech experts from around the world. The presentation began with the technical validation, the stress analyses, the wind tunnel data, the manufacturing feasibility. Then the team displayed something unexpected. Previously unidentified design features the AI had discovered by analyzing micro-variations in the V3's construction. The AI had identified subtle panel thickness variations across the wing sections. These variations optimized the structural strength exactly where it was needed while minimizing weight everywhere else. This is a modern technique called topology optimization, something engineers didn't formally develop until the 1980s using supercomputers. The Horten brothers had done it intuitively with slide rules and brilliant calculations. Then came the electromagnetic analysis. The reconstruction showed specific design choices, panel edge treatments, carefully oriented surface discontinuities, and the strategic placement of that charcoal-absorbing material, all forming a coherent radar mitigation strategy. This was not a random, lucky accident. An expert at the symposium admitted, "This is not random. This is systematic." But that wasn't what left them speechless. The truly shocking discovery came when the AI completed its analysis of the planned production variants, the V4 through V7 models which were never built. The reconstruction revealed a design evolution that suggested the Horten brothers weren't thinking about 1945. They were designing for 1950, 1960, or maybe even beyond. The V7 variant, the final planned version, included provisions for afterburning engines that didn't even exist yet. It had wing structures with reinforcement patterns that anticipated the stress loads of supersonic flutter. It had cockpit layouts suggesting pressurization systems and life support for sustained high-altitude operations above 45,000 feet. The AI found the logic for these upgrades embedded in the V3's existing structures. There were reinforcement patterns that made no sense for the V3's actual capabilities, but were perfectly positioned for the advanced variants. There were attachment hardpoints for uninstalled systems. There was a weight distribution that seemed wrong until you realized it was optimized for configurations 2 or 3 generations down the line. The Horten brothers had hidden their long-term vision inside the prototype itself, like seeds waiting for the right conditions to grow. One respected aerospace engineer examined this analysis for 3 days before admitting it. They were building a platform, he said, not just an aircraft, a technology framework that could evolve for decades. This is exactly how modern military aircraft are designed today. Engineers build expansion capability into Generation 1. The Hortens were doing this in 1944. The AI also revealed something nobody suspected. The Ho 229's design contained embedded solutions to problems the aviation industry wouldn't even encounter for years. For example, how do you prevent a jet engine's compressor from stalling when it's buried in a flying wing with deep, curved intakes? The answer was built into the intake geometry, with specific diffusion angles and boundary layer control that wouldn't be formally understood until the 1960s. How do you maintain control at transonic speeds near the sound barrier when shockwaves form and shift? The unique wing profile and control surface placement addressed it. The AI tested each solution in a virtual simulation across thousands of flight conditions. They worked, every single time. With full development funding and 5 more years, the Ho 229 lineage could have produced an aircraft matching 1960s fighter performance. We're talking speed, altitude, range, and stealth. An operational military aircraft 20 years ahead of its era. Then came the final chilling revelation. A researcher at the German Federal Archives, following AI-generated leads about production authorization patterns, discovered a sealed file from April 1945. It was a memo from Albert Speer, the armaments minister. Buried in the technical details was a single line. The Horten project is greenlit for immediate mass production. Initial order 200 units. 200 units. The order was dated April 10, 1945. This was exactly 3 weeks before Germany's surrender. The order was never fulfilled. The factories were overrun. But the authorization existed. The attendees at that symposium sat in stunned silence. They realized they were looking at a ghost. The quantum AI hadn't just reconstructed blueprints, it had reconstructed a possibility. And that possibility was terrifying in its sophistication, its completeness, and its terrifying nearness to reality. But what does this all mean for us right now? The AI's final warning. So what does this all mean? If you've been following this story, you know it's a wild ride. And let's be honest, many people are crazy about this story, and it's easy to see why. For the better part of a century, the Horten Ho 229 was treated as a historical footnote, a bizarre outlier from the desperate, dying days of a losing war. But now we know better. We're looking at a ghost. This isn't just any ghost story, though. This is a ghost that has been dragged back into the light, pieced together fragment by fragment, by an artificial intelligence. And the story this ghost is telling us is, to put it mildly, chilling. For decades, the official narrative was simple. The Ho 229 was just one of many wonder weapons that never wondered and barely worked. The common wisdom was that it was a desperate last-ditch effort, an act of scientific fantasy. Historians and engineers pointed to its strange construction. It wasn't a piece of junk exactly, but it was cobbled together from wood and glue. Why? Because the Third Reich was collapsing and had run out of precious aluminum and steel. They said it was unstable, a death trap for any pilot foolish enough to fly it. But the AI reconstruction completely shatters that myth. The AI reconstruction proves that the Horten Ho 229 wasn't just a flimsy prototype. The thing is, it was a sophisticated, coherent, and deeply advanced design. The AI analyzed the surviving V3 prototype, cross-referenced it with the Horten brothers' scattered notes, and simulated the aerodynamics. The conclusion: the wood and glue weren't just a sign of desperation, they were part of the design. The Hortens knew that a wooden airframe would be largely transparent to the crude radar systems of the 1940s. They even experimented with carbon-impregnated glue to absorb radar waves. This wasn't junk. It was a machine that was decades ahead of its time. And this is where the story gets really spooky. Go ahead and open a new tab. Google a picture of the B-2 Spirit stealth bomber, that $2 billion flying boomerang that represents the absolute peak of American military power. Now put that image next to the AI's reconstruction of the Ho 229. When you look at the modern B-2 Spirit stealth bomber, you can't unsee the Ho 229. The resemblance is not just uncanny, it's practically identical. This is not a coincidence. This is not convergent evolution. This is a direct technological bloodline. Let's just tick the boxes. Both are flying wings. No separate fuselage, no tail. Just one giant single sweeping wing. Both bury their engines deep inside that wing, shielding their hot exhaust from heat-seeking missiles and smoothing out the radar profile. Both lack a tail. That's critical. Tails are massive radar reflectors. Getting rid of them is the first step to becoming invisible. Both are designed to be invisible to radar. The B-2 uses high-tech, classified radar-absorbent materials and complex computer-modeled angles. The Ho 229 used carbon-laced plywood and special radar-absorbing glue. The materials are worlds apart, but the physics and the intent are identical. The AI's reconstruction shows a clear design lineage. It proves this wasn't an accident. The principles the Horten brothers were working on in 1944 with slide rules and intuition are the same principles that define the most advanced aircraft in the sky today. Think about that for a second. What Reimar and Walter Horten figured out in a German workshop with pencils and paper is the same core concept that teams of engineers at Northrop Grumman, backed by billions of dollars and supercomputers, figured out in the 1980s. The B-2 is, in many ways, the Ho 229's grandchild, finally realizing the potential of that original, terrifying design. The ghost of 1944 is flying in our skies right now, just wearing a different flag. This is precisely why this matters so much. The AI reconstruction has done more than just solve an 80-year-old puzzle. This isn't just a win for aviation geeks or military historians, it's changed our understanding of history. We love to think of history as a neat, linear progression. First, we had biplanes, then piston-engine fighters, then the first jets, and then, much later, stealth. But the Ho 229 throws a massive wrench in that clean timeline. It debunks the myth that this kind of technology was impossible in the 1940s. The accepted wisdom was that true stealth was a child of the digital age, born from computer processing power that simply didn't exist back then. Wrong. It was not only possible, it was built. And here's the most terrifying part of all. It was just weeks away from being produced. The AI data, combined with recovered manufacturing records, shows the production line was being set up. The jet-powered prototypes worked. If the war had dragged on for just 6 more months, what would a squadron of these radar-invisible ghost jets have done to the unescorted Allied bomber formations over Europe? It's a question that history is very, very glad we don't have to answer. Now, we do have to pump the brakes just a little. But here's the down-to-earth part. Are we missing a key detail? Did all this happen overnight? Number. This wasn't some mad scientist fever dream. Reimar and Walter Horten weren't just lucky. The Horten brothers had been working on flying wing design since the 1930s. They were obsessed. They built and flew dozens of gliders, all based on this all-wing concept. They believed, decades before anyone else, that it was the most efficient and perfect way for a machine to fly. The Ho 229 wasn't their first try, it was their masterpiece. This was the culmination of their life's work. They had spent 15 years failing, learning, tweaking, and perfecting their designs. What the war gave them was a blank check from a desperate government and a powerful new piece of tech, the jet engine. What the AI did was finally show us the completeness of their vision. Before this, all we had was the broken V3 prototype, the one captured by American troops and stuck in a warehouse. It looked primitive, incomplete. But the AI, by cross-referencing every known blueprint, every test flight note, and every scrap of data, rebuilt the intended design. It showed us that they weren't just building a fighter, they were building a platform for the future. They were designing a machine that could be a bomber, a reconnaissance plane, or a night fighter. They were building the B-2 40 years early. And this brings us to the biggest, most unnerving conclusion of all. This whole story opens up a new set of questions. This isn't just about one lost airplane. If an AI can reconstruct this, what else can it reconstruct? Think about it. History is full of holes, of lost knowledge, of burned libraries and shattered machines. How many other lost designs, burned blueprints, or forgotten technologies are out there waiting in fragments? What about the other wonder weapons that were dismissed as fantasy? What about technologies from even further back? We are surrounded by historical puzzles where we only have a few of the pieces. The AI has shown it can see patterns in the chaos that the human eye misses. A human historian can look at 1,000 documents and see 1,000 facts. An AI can look at the same 1,000 documents and see the one hidden design that connects them all. It can connect the dots across 80 years and thousands of pieces of data. The potential is enormous, but to put it mildly, it's also a little unsettling. We are, right now, building a tool that can unburn the libraries of the past. It can resurrect concepts that were lost for a reason, or maybe just by accident. We are just now beginning to understand the past thanks to a technology from the future, and it's forcing us to reevaluate everything we thought we knew. The Ho 229 was a ghost that almost changed the world. For 80 years, it's been a silent wooden mystery. Now, thanks to AI, that ghost is back, and it's finally telling its secrets. And you have to wonder, what other ghosts are waiting in line right behind it? Outro, was the Ho 229 a lucky accident or true genius? Let us know below. Like and subscribe for more hidden history.